Hello students, in our series of multiple integrals, today we will discuss about a special integral, Dirichlet integral. Now, what is Dirichlet integral? Any integral, either it is a double integral or a triple integral over an area or a volume of this type, x raised to the power n minus 1, y raised to the power n minus 1, z raised to the power p minus 1 dx dy dz, where b is the volume bounded by x, y, z such that x is greater than equal to 0, y is greater than equal to 0, z is greater than equal to 0, and x plus y plus z is less than equal to 1. So again, this type of integral, either it may be a double integral or triple integral. If it is a double integral, we will take over an area, and if it is a triple integral, we will take it over a volume. And our region or this volume will always be in the first quadrant or first octant, and it would be in this special form. This type of integral are known as Dirichlet's integral. Okay, now we will find an expression for this type of Dirichlet integral. Now, you know the limits that v can also be defined as x, y, z, where z lies between 0 and 1 minus x minus y lies between 0 and 1 minus x, and x lies between 0 and 1. I think you have studied it in triple integral, that how we can find these limits. So our integral I would be equal to, as limits of z contains two variable x and y, so we must integrate with respect to z first. As limit of y contains only one variable x, so after z we will integrate with respect to y, and as the limits of x are constant, so we will integrate with respect to x at the last. So our integral is x raised to the power m minus 1, y raised to the power n minus 1, z raised to the power p minus 1, dz dy dx. So as the limits of x is function of x and y, so we would integrate with respect to x, and when we would integrate with respect to z, x and y would remain constant. So this integration would be equal to 0 to 1, 0 to 1 minus x, x raised to the power m minus 1, y raised to the power n minus 1. Now the integration of z, keeping x and y constant, it would be z raised to the power p over p with the limits 0 to 1 minus x minus y dy dx. Again, students, keep in mind, when we are integrating with respect to z, then x and y would remain constant. Second thing, why we are integrating with respect to z first? Because limits of z contains both x and y, so we would integrate with respect to z first, and keeping x and y constant. Now it would be equal to 0 to 1, 0 to 1 minus x, x raised to the power m minus 1, y raised to the power n minus 1. When we will put, it will become 1 minus x minus y raised to the power p over p dy. Now we have integrated with respect to z. Now again, as limits of y contains x, so we would integrate with respect to y, keeping x constant. But we are looking at the integral, we would use beta and gamma function, and we can easily convert this in form of beta function. For that we will use substitution. Put y is equal to 1 minus x into t, then d of y will be equal to 1 minus x into d of t. Again, students, we are integrating with respect to y, keeping x as constant. So we have taken the substitution. Y is equal to 1 minus x into t, dy, its derivative would become 1 minus x being constant, d of t. Again, we will find the limits when y is equal to 0. When y is equal to 0, t would be equal to 0. Again, when y is equal to 1 minus x, then t would be equal to 1. So our integral would become 0 to 1. It would become 0 to 1 x raised to the power m minus 1. Here we will put 1 minus x raised to the t raised to the power n minus 1 into 1 minus x minus 1 minus x into t raised to the power p, and I am writing this constant 1 by p outside, into d of y become 1 minus x into d of t, and at last d of x. So we have made the substitution. Y is equal to 1 minus x into t. We take the derivative, we find out the limits, and we have it. So it would become 1 by p integral 0 to 1, as we are integrating with respect to t, keeping x as constant. So it would become x raised to the power m minus 1. From here it would be 1 minus x raised to the power n minus 1, t raised to the power n minus 1. From here we will take common 1 minus x raised to the power p, and we will left with 1 minus t raised to the power p, 1 minus x, d of t, d of x. Again look, it is x raised to the power n minus 1. Here we can write 1 minus x raised to the power n minus 1, t raised to the power n minus 1. From here we have taken the common, 1 minus x is common, and we will left with 1 minus t raised to the power p, 1 minus x, dt, dx. Now we can combine the terms. It will be equal to 1 by p integral. Here we have left one integral 0 to 1. 0 to 1. Now we are integrating with respect to t, and x is constant, so I am writing terms containing x outside. Here 1 minus x raised to the power n minus 1, 1 minus x raised to the power p, 1 minus x, so it would become 1 minus x raised to the power n plus p, and here it is integral 0 to 1 t raised to the power n minus 1, 1 minus t raised to the power p, d of t, Now students, we know the definition of beta of mn. Beta of mn is equal to integral 0 to 1 x raised to the power m minus 1 minus x raised to the power n minus 1 d of x. I think you know the definition of beta function, and even you can check it out in our earlier lectures. So we are using the same here. It can be written as 1 by p, and it is beta of n p plus 1. Using the definition, you can compare and you can write it as this, and we are left with integral 0 to 1 x raised to the power m minus 1 minus x raised to the power n plus p d of x. And again you are watching the same thing, same type of integral. Again we can write it in form of beta function, and it would be equal to 1 by p beta of n p plus 1, and it will be equal to beta of m and n plus p plus 1. Now student, again look, there is any triple integral over this type of volume. Always you have to keep in mind that Dirichlet integral would always be integrated over the spatial region or the spatial volume. You have to convert your region or the volume always in this spatial form when you will apply these type of results. So in this way we would integrate. Now we can simplify this as well. I am just erasing from here. Now we have find that this integral is equal to 1 over p beta of n p plus 1 and beta of m n plus p plus 1. Now we know the relation between beta and gamma function, and what is that? That beta of mn is equal to gamma of m, gamma of n over gamma of m plus n. I am using the relation between beta and gamma function, and it would be equal to 1 by p gamma of n gamma of p plus 1 over gamma of n plus p plus 1 into, again write this beta function as gamma function. It will become gamma of m gamma of n plus p plus 1 over gamma of m plus n plus p plus 1, and it would be equal to, this would cancel out and we would left with 1 by p gamma of m gamma of n. Now it is gamma of p plus 1 over gamma of m plus n plus p plus 1. Now again students, when we studied beta and gamma function, we have studied the recurrence relation for gamma function, and what it was? It was gamma of n is equal to n minus 1 gamma of n minus 1. So it would be equal to 1 by p gamma of m gamma of n gamma of we use the reconciliation, it will become p into gamma of p over gamma of m plus n plus p plus 1, and we will cancel out this p, and it would be equal to gamma of m gamma of n gamma of p over gamma of m plus n plus p plus 1. So we can direct use this result for Dirichlet integral, but for that we must look at the volume. It must be of this form and it must be in the first octant. Only then we can apply this result, that this type of double or triple integral over this type special type of area or volume can be directly solved using this integral, and it would be always equal to gamma of n gamma of p over gamma of m plus n plus p plus 1. So this integral is known as Dirichlet integral. So you can learn the result from here. It would be gamma of m gamma of n gamma of p over gamma of m plus n plus p plus 1. So we will use this result directly when we will solve our problems. So students, if we have to write the same result for double integral, then it would be Dirichlet integral would be over the region R, and it would be equal to gamma of m gamma of n over gamma of m plus n plus 1, where our region would be in first quadrant and this. So students, if we have to write our Dirichlet integral for double integral, then it would be double integral x raised to the power m minus 1 y raised to the power n minus 1 dx dy over this special region, and it would be equal to gamma of n and gamma of m plus n plus 1. Now if we get some another type of region, that is to show double integral over the region R, x raised to the power m minus 1 y raised to the power n minus 1 dx dy would be equal to gamma of m gamma of n over gamma of m plus n plus 1 h raised to the power m plus 1, when where R is equal to the region bounded by x is greater than equal to 0, y is greater than equal to 0, and x plus y is less than equal to h. So just compare the two. Here it was x plus y is less than equal to 1, and we can directly use the result, but here it is x plus y is less than equal to h. So if there is some another constant other than 1, then we have to show that this integral would be equal to this. How we can show that? Now our region is bounded in this way, so our integral is R x raised to the power m minus 1 y raised to the power n minus 1 dx dy. Now just substitute, put x is equal to h into u, y is equal to h into v. Why I have put in this way? Because when we will replace x by hu, y by hv, then it will become u plus v is less than equal to 1 by cancelling h on the both sides. So we will convert this region in the same format. So our d of x would be equal to h into du, dy would be equal to h into dv. So our double integral would become over some new region that will be defined in form of u and v. It would be hu raised to the power m minus 1, hu raised to the power n minus 1, h square du dv. I have replaced dx by h into du, dy by h into dv. So dx dy would become h square du dv. So we will get, first write the region where r dash is the region bounded by uv such that u is greater than equal to 0, v is greater than equal to 0, and u plus v is less than equal to 1. Students, just check it out here. When we will replace x by hu, y by hv, then h will come out as common and we can cancel out and we can write this. So now you can watch that this region is in the same format. So we can apply the result of Dirichlet integral directly over this integral. So it would be equal to double integral over the region r dash. Now h, from here power would be m minus 1, from here power of h would be n minus 1 and h square. So the total power would be h raised to the power n plus 1, u raised to the power m minus 1, v raised to the power n minus 1 du dv. So it would be equal to h raised to the power m plus 1 double integral over the region r dash, u raised to the power m minus 1, v raised to the power n minus 1 du dv, where r dash is the region bounded by u is greater than equal to 0, v is greater than equal to 0, and u plus v is less than equal to 1. Now over this integral, where region is in the standard form of Dirichlet integral, its value can be found using this integral, and it would be equal to h raised to the power m plus n gamma of m gamma of n over gamma of m plus n plus 1. So students, in this way, to solve the many problems, we will find our substitution using the region or the volume provided to us. We have to use the substitution in such a way that we can convert our region in the form of Dirichlet integral. So use the substitution and we find the value of this integral. Okay student, now take one problem. Find the volume of solid bounded by the coordinate planes and the surface this. So student, we know how we can find the volume using multiple integrals. Volume will be equal to triple integral 1 into dx dy dz. I think you have studied it in triple integral, that how we find the volume of a solid, and where it is bounded by v is x y z, bounded by coordinate planes. It means x is greater than equal to 0, y is greater than equal to 0, z is greater than equal to 0, and the surface this x by a raised to the power 1 by 2 plus y by b raised to the power 1 by 2 plus z by c raised to the power 1 by 2 is less than equal to 1. It means our solid is bounded by coordinate planes and this, so that's why I have written it in less than equal to. Now if we compare our this volume with the standard form of Dirichlet integral, then it was in the standard form, it was x is greater than equal to 0, y is greater than equal to 0, z is greater than equal to 0, and x plus y plus z less than equal to 1. It means there must be no any power, there must be no any constant multiplied to it. So we will use the substitution. Put x by a raised to the power 1 by 2 is equal to u, y by b raised to the power 1 by 2 is equal to b, and z by c raised to the power 1 by 2 is equal to w. Students, again look, we have to convert this volume in the standard form of Dirichlet integral. So you have to take your substitution by converting it in form of standard form. From here x would be equal to a u square, y would be equal to b square, and z would be equal to cw square, and d of x would be equal to 2au du, dy would be equal to 2b dv, sorry, it would be 2bv dv, and dz would be equal to 2cw dw. It means our volume will be equal to triple integral over the new v dash, where it would be dx dy dz. So it would become 2 into 2 into 2, 8, a b c u v w du dv dw. Again look, here it was 1, so 1. Now dx dy dz, we multiplied them, 2 into 2 into 2, 8, a b c u v w du dv dw, where v dash is the volume bounded by. From here we replace x by au square, y by bv square, z by cw square. It would be u is greater than equal to 0, v is greater than equal to 0, w is greater than equal to 0, and it is u plus v plus w is less than equal to 1. Now it is in the form of Dirichlet integral. So it is 8abc triple integral u raised to the power 2 minus 1, v raised to the power 2 minus 1, w raised to the power 2 minus 1 du dv dw, where over the volume v dash, and where v dash is uvw, where u is greater than equal to 0, v is greater than equal to 0, w is greater than equal to 0, u plus v plus w is less than equal to 1. Now if we compare this integral and this volume, it is bounded by this with the standard form of Dirichlet integral, both are same, so we can directly write its value, and it would be equal to 8 abc gamma of 2 gamma of 2 gamma of 2 over gamma of 2 plus 2 plus 2 plus 1, as here m and p all three are 2. So it would be equal to 8abc, it is gamma of 2 raised to the power 3 over gamma of 7. And we can solve, we can find the value of gamma 2 and gamma 7. We know when we studied gamma function that if n is positive integer, gamma of n is equal to factorial of n minus 1, especially for positive integer. So it would be equal to ABC, it would be factorial 1 raised to the power 3 over factorial 6, and now we can find their values, and it would be factorial 1 is 1 and factorial 6 is 720, and it would be equal to ABC over 90. So you can solve it at your own. Important thing is when we have to use Dirichlet integral, then we have to convert using the suitable substitution our region or the volume provided to us in form of the standard form. And for that we will find the substitutions which are suitable to convert that volume in the standard form of the Dirichlet integral. So student, in this way I think you got the concept of Dirichlet integrals. Thank you.